Yesterday we worked on separating them, right, to understand how to separate different ones. Today we're going to work on actually solving them, okay? So we have that says given the differential equation dy over dx equals 2x over y, we're going to solve for y as a function of x. So the first step is to separate like we did yesterday. So we're going to multiply both sides by what? Dx. Okay. So I'm going to have dy, well, let me just rewrite it. Dy over dx equals 2x over y. Then I'm going to multiply both sides by dx. So dy equals 2x over y times dy. No, times dx. Good Lord. Times dx. What do I do next? Multiply by y. So this is going to give me y times dy equals 2x dx. Oh, there we go. Okay. Well, I mean, we could have done it all in one step. I just didn't want to lose you. Okay, so it's okay to do it all in one step. Just don't make up math. You with me? So now we integrate. Okay, we're going to take the integral of both sides. You with me on that? So if I integrate y, that's y to the first. I add 1 to the exponent, so it becomes y squared. It does. That'll be y squared over what? Y squared over 2. Equals, so that's 2x, so I take x to the second and divide by what? 2, so that becomes x squared, and then I have plus c. And I only put the plus c on one side. Okay, does that make sense? Because if I did, it wouldn't matter. Well, it wouldn't matter, because if I did plus c on both sides, then I'm basically, we don't know that they're the same. So if I subtract it over here, it still just becomes a constant. Here's what you have to remember about this. C is a constant, right? Do you have a question? What's the question? Because it's y to the first, so we add 1 to the exponent and divide by 2. No, you're not ready. Well, it was 2, so I skipped that step. All right, so his question is, so like right here, this would actually be, yeah, I just skipped it, so it's, you know. No, it's okay. And it's fine to go step by step. Maybe I should, I don't know. All right, but here, listen very carefully. C is a constant, right? It's some number. We don't know what it is. I need to move that 2, okay? So I'm going to multiply both sides by 2. When I do that, so I'm going to multiply this by 2 and this by 2. Okay, does that make sense? So these 2's are going to cancel out, so I end up with y squared. That's equal to 2 times x squared is 2x squared. 2 times a constant is still a constant, so it is plus c. It is not plus 2c. Okay? C is a constant, not a variable, even though we're kind of treating it like a variable. It means it's something that doesn't change. So x is a variable. It varies depending on what I substitute in. C is a constant. So if that's plus 5, it's always plus, the 5 doesn't change. We just don't know what the number is yet. Does that make sense? Okay, so that's a big change here. No plus 2c. You with me? No, go ahead. Because we are solving for y. I probably should have said that from the beginning. Well, actually I did, because it says, no, you're fine. It says solve for y as a function of x. Because c is a constant. We don't know what it is, but it's some constant times 2 is still a constant. And that's all we care about is that it's a constant. I know that's confusing at first. Okay? And I will tell you, some people, including Miss Bruce, and I just chose not to do this, but when she does this and she multiplies, she changes it to c sub 1, just to kind of note that, okay, yeah, maybe, but we still don't even know what it is. And in the end, it doesn't matter if it's c sub 1 or c. Some people change it to k. It's still a constant. We just don't put the 2 in front of it. Okay? We're good on that? Which, again, I know is weird, but you'll get used to it. Like, it's just kind of strange because you're so used to having to distribute, and it's a bad thing if you don't. This kind of changes everything. All right? So now how do we undo the square? Square root. Okay, so when I take the square root, y is equal to plus or minus the square root of 2x squared plus c. And I'm going to just ignore that sub 1 there. So yes, so what this is y as a function of x. This is your, and it's what it says right here. Your answer, that answer is the general solution. We are going to find the particular solution because they gave us this. Okay? Now, so we can find c. Now in this particular case, we solved all the way to y because it specifically said to, then we're going to substitute it in. You don't always have to, when you know you're going to have to go, you have enough information to go find c, we don't have to always go down to y, okay? You can, but you don't have to, and there's some reasons you don't want to. Hence what I told y'all yesterday about the conversation Ms. Bruce and I had. We still can't really explain it very well. And I was like, well, if she can't explain it very well, I don't know what the heck I'm supposed to do. So, all right, so if we're given this initial condition, now here's the thing. We have plus or minus. We have to decide if we're using plus or minus or both. Well, when one is our x, right? When we substitute in the x, we're going to get a negative answer out, right? So that means I'm using the negative one. So I'm going to have that negative 3 is equal to the negative square root. That's how you know which one to use, okay? Of 2 times 1 squared plus c. Now, even though c is a constant, we're treating it like a variable because we're solving for it. Does that make sense? Okay. All right, so then this is going to give me negative, actually I can, oops. I want to undo, oh my gosh, this board. I'm sorry, y'all, I'm going to get better. I need to undo the square, so what am I going to do? Square it, so I'm going to square both sides, which means they now both become positive, right? So 9 equals that negative squared, and that's going to be 2 times 1 is 2, 2 plus c. So what does c equal? 7. So you might think, well, it really didn't matter if I used positive or negative here, but it does because when we write our particular solution, we have y equals negative square root of 2, oh my gosh, my knuckles are writing on the board for me, 2x squared plus 7. Okay, and that's it. So this was my general solution. At that time, we didn't know if it was plus or minus. This is my particular solution because they gave me this here. Okay? What questions do you have? Uh-huh. Because it was either one or the other. It can't be both if we have a specific value that we got out. So when I substitute in 1, that's my x value. My y is negative. So whatever my output is has to be negative. That's how I know it's the negative 1. Okay. It was based on this, and that number there helping me. Okay. What else? Anything else? We good? Okay. Let's look at this next one. So this one we have y prime. We're going to change that to dy dx. So dy dx equals x squared times the square root of y. We good? So I'm going to start by multiplying both sides by dx, so I get dy equals x squared times the square root of y times dx. That looks like the absolute value of x, but it's not. It's because my pen's dragging. I will get better. What do I do now? Divide by the square root of y. Okay, so dy divided by the square root of y equals x squared dx. Now, I think I would like to change this to y to the negative 1/2 times dy, and that equals x squared dx. Everybody with me on why I did what I did? Okay. So I've cleaned it up a little bit. I have my y's and my x's separated. I could go all the way to solve for y at this point, but I really oh, not at this point. I need to integrate first, and then, but we'll talk about that. So I need to integrate at this point. Once I've got them separated, we separate, then we integrate, right? So now we're going to take the integral of both sides to get rid of the dy and the dx. I was jumping ahead of myself. So for the left side, I add 1 to get y to the 1/2. And then I divide by 1/2, which is the same, times 2. Equals, I add 1 to the exponent to get x cubed and divide by 3, right? So x cubed over 3, and then plus c. It could have happened. Yes. We'll get there, though. We're not going to get there yet. All right. So everybody with me so far? Here's where I meant to say what I was about to say there, is that I could go all the way and solve for y, but it doesn't ask me to do that, like just y as a function of x to begin with. It gives me this. So at this point, I can go ahead and substitute it in, and sometimes that makes it a little bit more efficient. Kind of saves you some steps. All right? And so I'm going to have 2. What's y? 4. Yeah, it's the square root of 4. Good. 2 times the square root of 4 equals 3 cubed divided by 3 plus c. Okay. Everybody with me? All right. So 2 times the square root of 4 is 4. That's equal to 3 cubed divided by 3 is just 3 squared, right? So that's just 9 plus c. So c is equal to -5. Okay? Now that I have that, I'm going to go and substitute it into here. And now I need to solve for y. I mean, I'm going to substitute it in first, but I get 2, and I can go ahead and say the square root of y if I want, equals x cubed over 3 minus 5. Okay. Solving for y, what would I do next? Divide by 2, so I still have the square root of y equals, what's x cubed over 3 divided by 2? Because I'm dividing by 2, not multiplying. Because you said 2 times x cubed. So when I divide by 2, it's the same as multiplying by 1/2, so that does become over 6. You see the difference there? That's okay. It happens, I know. Minus 5 over 2, right? So now that it's no longer literally a c, like here, if I had divided both sides by 2, this would have stayed c. But since c is a number now, I actually divide by 2. Okay? There's the difference there. Now, how do I undo a square? I square it. So y is equal to x cubed over 6 minus 5/2 quantity squared. And that's my answer. What questions do you have? Okay. So we're going to solve this one with this initial condition. So what's the first thing we do? Separate. So go ahead and separate. I'll give you a second to separate, and then I'll write it down because I don't want you just copying mine. So I did it all in one step, which I'm not saying you should do at this point. You'll get there. There's nothing wrong with it, but it may cause you to do some weird things sometimes, so it's not a bad idea to do it in a couple steps, okay? Are we all separated okay? Now, before we integrate, do you think we want to change anything to make it a little bit easier on us? Yeah, y to the -2. I would definitely do that. So I'm going to have y to the -2 times dy equals 4x dx. Now, what do I do next? Integrate. Yes, so I'm going to integrate both sides. Go ahead and do that, then we'll see what we get. So it's okay if you didn't write this step. I decided to go ahead, especially since you're not just following along with me. Write this down, so this is going to become it's the same thing. We good? What do we do now? Find C. Go ahead and find C. After we find C, what do we do? Yep, substitute it in and solve for Y. Go ahead and try that, and then I'll walk you through it. Uh-huh. Yes, yeah, so once I find C, I would just go back up to the last one that I had and substitute it in there and then solve for Y. Mm-hmm. Oh, because this is, when I substitute in, this is, do you understand how I got here? Okay, so then I substituted this in here, and that's where it came from. Oops. Okay, so there's a couple of different ways to get y out of the denominator. You can, I think I heard somebody say you can multiply by y and then divide by the other. That works. You can also just take the reciprocal of both. It's the same thing either way. So this actually can become negative y equals 1 over 2x squared minus 9 because of that. If I multiply both sides by y and then divide by this, that's what's happening there. Okay? But I don't want negative y, I want y. So y is equal to negative 1 over 2x squared minus 9. Or, what do you have? That's fine. But then you still have it, okay, but here's the difference. You can't pull that out there because then that means the whole thing's negative. It would need to stay on the 2. So it's okay, but if you do that, yes, yes. A 1's a 50th, yeah. All right, are we good? Okay, so I want you